So I mentioned earlier at the beginning where we have this Ask the Community session, which is an experiment. And we had asked people in advance to contribute questions if they have any, to ask out to the community. We have some questions that came in and we can go through those. What I would encourage you to do, I think we'll have some discussion here in this first session about some of the questions that came up. I have one or two quick things to show. At the end, Axel raised a very interesting point about tautomers. Those of you who've been at one of these before know that tautomer discussions can rapidly escalate completely out of control. So what we're going to do with that is at the end of this, Axel will present what he has seen about tautomers, just so you are all aware of it, because I think it is important information that is not perhaps broadly enough known in our community. And then people who want to continue to discuss that will stay in here after 5:30. And then everybody else can go have a beer or something while we stay here and Roger rants, my blood pressure goes up, and we have an interesting discussion. That's all I'll say about that. So that's this. So what we have, you guys have some slides, right? For the first question, we'll start with that. So the other thing is, if this session or anything else that comes out of it inspires additional questions from you afterwards, please just ask them in the Discord and we'll see about if we can figure out ways to continue this going forward. Again, this is an experiment. Please bear with us. Paul, do you want to actually ask the question? You say only one, but I see 9.
Pick one, but not an arbitrary one, please. This one. No? No. And Zoom is still working, right?
Zoom should still be working.
Okay, now it's your show.
Hello, everyone. My name is Michel, currently doing my PhD in the Trudowski group, and this is our newest addition, Alexander, who is doing his master's thesis, and we were quite delighted for this new category as a community, because for the also forced because for the pKa measurements using NMR, we were facing some problems. But I saw that some people in the community, I think Patrick, for example, has experience with FNMR. So we are glad to have your input on this problem. And with that, I will hand over to Alexander to give more details about this problem.
Okay. So as said, our project is pKa determination by HMNMR measurements. And so the basic thing what we're doing is doing NMR measurements at different pH values and then tracking individual peaks through all the measurements and plotting the chemical shift against the pH values. This method, while not a common method, has several advantages. Is the laser pointer still on? How do I switch the laser pointer on? Oh, okay. Okay, so yeah. So the key point is that the chemical shifts can be assigned to different functional groups. For example, the green one here on top corresponds to the aromatic hydrogen atom belonging to the functional group in the aromatic ring, while the red curve here corresponds to the upper functional group in the side chain. And as such, the different pKa values can be determined individually and so mostly independent of each other, allowing fairly precise determination of the pKa values. So the problem we're facing so far is we tried to automate the entire process by uploading raw data into Python with using the module NMR glue. We found to that, but the main issues in that case are for one, that the baseline correction is not really working properly. And another problem is finding peaks and then tracking them through all the measurements, especially since oftentimes smaller peaks tend to be relevant in some cases. And another problem is peaks moving through other peaks, which we have been having difficulties tracking. And so in this case, we wanted to ask whether someone had experience working with NMR data or other suggestion on how to include RDKit into our process.
I will run. Run.
Yeah, so I can give short comments on this. So the few times I have now worked with NMR raw data, it's generally been with annotated peaks. I would be hesitant for my applications to use non-manually annotated peaks. Getting these peaks out of the different file formats is then fairly easy. I'm assuming you're using like a Bruker or something system, and then yeah, you can get that out pretty easily, which is just XML parsing at that point. Yeah, signal to noise and all of that is then an issue for the manual annotator, which is also a little bit of a problem. But no, so on a larger scale of a few hundred sort of measurements, for example, I would not have an automatic peak detection method that would be foolproof for the different signal to noise ratio things. We would really do this by manual annotation and then take out the manual annotations from the spectra themselves. And there's some details there on file formats and whatever that we can talk about. But yeah, so if manual annotation is a problem for you, then this will turn into a bigger problem, I would say. Yeah, so I would go through the spectra on Topspin and then manually annotate the peaks, and then getting that out of the Topspin file is fairly easy.
Good. No, we have Nick. Yeah, I come over, Nick.
Thanks. So first a comment, I would definitely reach out to the Baumann Lab and Braunschweig, because these are the guys that work with that kind of data for quite a while, and I know they do this. That's one thing I would do. The question for me is, do you actually need, because this is longitudinal data, if you look at it from a different angle, right? In theory, you can need to put on my glasses. You can think of this not as individual measurements and individual peaks. So if you think about this maybe as longitudinal data where you have a time axis over the pH, then you can think, if you look at, let's say, video analysis data for cage studies or whatever. So I think Napari is one of the tools that people are using for this. I really wonder if you need the actual assignment, or if you look at it over time, where the time is actually the pH change, if you could actually use image analysis tools for this. I've seen something along the lines working, so it could be something at least to look into. If that is something you can try and do here, because then maybe you actually see the change over time, and you don't have to do the individual peak. You would actually see the change of the pieces, so you don't see it as separate experiments. That would be something I would maybe try and have a look into. I can try and dig out some papers, but it's been a while since I looked at this. Sorry.
Oh, yeah. Frequent hitter win. Well, thanks.
Yeah, I have just one short comment on this, and this is that, as was suggested here before, the initial thing you want to do is not something you want to do in RDKit, because it's a single processing program. And actually, there are many programs that are very similar to this one. For example, when you do analysis of a sound signal, you want to assign frequencies. This is very similar. This is very similar problem. So you have a frequency versus time trade-off. When you imagine what you are looking at, it's like let's say your y-axis. That's the spectrum. That's where you have the frequencies of interest. It evolves over time, and maybe some of the lines, they will split open or they will converge depending on what's happening in function of pH. And this means that the type of analysis you want to do is really like some simple time frequency analysis, which is like you can do this in SciPy. It's very common. It's a very common problem, and probably if you have relatively similar data, like they're all benzoic acids and such things, it's all measured on the same device. Maybe after a bit of playing around with it, you will find just the right setting where you can really see the lines nicely appearing.
Already 15 minutes for one to take.
So I think what I heard from both of those answers, and just to summarize that, because I think it may be helpful, is that there are approaches for looking at the series of spectra to identify the interesting parts of the spectra. And then once you've identified that, then it becomes a peak assignment problem to figure out what the protons are that you're looking at. And that would be the part where the RDKit comes in, right? So there's the signal processing part, which is identifying what's interesting. And then once you've done that, there's a human part, potentially with help from software, to figure out which protons are creating those interesting peaks. Does that kind of summarize what you guys were saying? And does that help you guys? Okay, yeah, cool. Anything else for them?
Discord? I mean, there are some topics in the Discord. Okay. Okay. It's turned off. No, it should work.
Okay, you can hear me through this, right? So this will theoretically show up on Zoom as well.
Da hat er promoviert nämlich, der nicht Stiefel, aber ich bringe euch nicht. Oh, sorry. Hat's ja auch.
One of the questions on Discord was about polymers. And this is one I can answer very quickly. So I figured I would go ahead and answer it. So there's a question, it's a question basically about what you can do with the RDKit and polymers. And if you can do enumeration, if there's any work that you can do with them. And so the answer to that is yes, there are some things you can do with polymers. I figured I would briefly show a little bit of what you can do. Tomorrow in the What's New session, I'll show a little bit more, which is about how to tell if two polymers are different from each other based upon the chemical input format. But I'll just start now with something very basic. So what I've done here is I've sketched one representation of a polymer I just made up in Marvin Sketch. I'm going to be using Marvin for this. You can do the same thing in ChemDraw or in BioViaDraw. The file format that you want to use for this is V3000 mol files or V3000 SDF. You don't want to do it in anything else because things will get lost. But what I've done is I've drawn the monomer and then I drew brackets around it to indicate that it is a monomer. And that is now in the output file. If I copy that out and paste it into Jupyter, you should see it shows up in the output file as this S group information at the bottom. Most of you don't need to worry about what this is. This is a very compact definition of what it is that I drew. So it shows where the brackets are, and it says that this set of atoms is part of the repeating unit. And it says that it is a head to tail polymer. So it says that I'm going to connect the head to the tail when I actually enumerate the polymer. I could have also just said that this is a head-to-head polymer, so then it goes head-to-head and then tail-to-tail, head-to-head, tail-to-tail. But I picked head-tail. And there's a bit of additional information in here. Again, it's not super important to you. The important thing is that you need to do this in V3000 mol in order to get the information in a usable format. So I have it. I can read that in. So this is a live notebook. Hopefully nothing goes wrong. So I read the monomer in. If you draw that in a notebook, the RDKit now, as of a couple of releases ago, knows how to draw these things. So you see the same information in the notebook as we saw in Marvin, right? So you see that it's recognized. It knows that there's brackets and it knows it's head tail and it's a polymer. One of the things you can do with that is sometimes useful is to actually enumerate. the polymer. So I can take the monomer and enumerate multiple instances of the monomer in order to get what those pieces of what the polymer itself might actually look like. The ArcticKit has an RDMol enumerator. It has the capability to do this. So if I give it one of these objects, I can say I want to enumerate this. I want to go up to 3 repeats. And when I do that, I get a bundle, which is a collection of molecules. Those do not have coordinates associated with them, so I have to go in and generate coordinates in order to get decent drawings. But once I've done that, I can then see the first element of the bundle. There's basically nothing there, so that's n equals 0. Then for n equals 1, I have my monomer. N equals 2, I have 2 of the monomers connected together, and I can just blow that out as far as I want. So if I want to go up to 10, I can close my parentheses. And you can see I can start to enumerate multiple instances of the monomer or of the polymer. Obviously, I'm not going to go to 1,000 with this or 10,000 or whatever. I mean, you could, but it wouldn't, the drawings wouldn't be very good and it would take a while. Anyways, that's one very basic thing you can do. So you just to make the point of what we saw, you can actually read monomers in as long as they're stored in this, or polymers, as long as they're stored in this very particular way. You can read them in. The ArcticKit recognizes it, you can enumerate them, and as we'll see tomorrow, you can actually calculate hashes on them, so you can tell if 2 of these things are the same, or if they're different. So hopefully that question came in over Discord. Hopefully that was useful to the person who asked it. Are there any questions in here about it? Roger? I'm scared now. Excuse me? Let's see if, so Roger asked if, I'm going to rephrase it. He's going to ask, he asked if the ArcticKit can process it from CX Miles. I'm not sure. Let's check. And if not, why? And if the why, if not why, is because I haven't gotten there yet. For people who don't know, CX Miles is an extension to Smiles. So you can see this is a Smiles at the beginning, and then there's all this crap at the end, which is this additional information. The additional information is all of that S group stuff that we saw in the V3000 mole block. This CX Miles is something that the Chemaxon guys developed. It's quite useful what you can do. The ArcticKit supports a fair subset of it, but not everything. So I don't know what's going to happen when I do this. Yeah, so I don't think this is going to enumerate. Oh. Look, it works. Okay, so what went wrong? Yeah, the depiction is screwed up, but it actually did the right thing. Okay, so obviously something has happened with not recognizing that it needs to draw the brackets, but it does parse the information out so that you can enumerate the thing. Thanks for asking that, Roger. That was a pleasant surprise. Yes. Are there any other questions? CX Miles isn't, just as a side, CX Miles is a really interesting thing. It does allow you to capture a lot of additional information that doesn't work in Smiles, and including, so we saw in Susan's presentation, there was some stuff about enhanced stereo, where you're expressing what you know or don't know about mixtures of stereoisomers, and that can all be encoded in CX Miles, and the ArcticKit will read all of that and work with it properly. It's a really interesting format. We strive to support as much of it as we can, but we don't have everything yet. Stefan?
Is there also an RDMol concatenator, basically, where you would basically give it a list of fragments, like you have one fragment here now that you enumerate.
Yeah. And
if you would have a list of fragments that you would concatenate.
So if you have a series of ArcticKit molecules, you can combine them very easily into one molecule using the combine moles function. But what that does is it takes the set of fragments and makes them into one molecule that has fragments.
Yeah, that's not what,
No, I know you want to do this. And then the next step would be you have to have some way to recognize on the fragments what you want to connect.
yes.
And then you would apply a reaction to it that
Yes.
connects the pieces that you want.
Yes, but that's clumsy.
Yes.
That would be, if you could do concat, basically, if you instead of basically enumerate, you would just have a list, and ideally this list could contain more than different fragments, different pieces, not just M. But the mechanism the same, is the head-to-tail connection.
Yeah.
You know what I'm getting at? This would be
I know, but this is not ask the community. This is a feature request.
okay. That's okay.
So now we
We
can pay
we
for
should
this.
follow up and you can give me details on exactly what you want. The way to phrase that is as ask the community for people that want to play diplomatically. Stefan doesn't care. If you want to play diplomatically is, I was wondering if the RDK could do this thing that I would like it to do. Right? There's one here. Nah, Paul will bring you a microphone.
It's all good, all good.
I was wondering if it would work for branching polymers enumeration.
I don't remember, and I'm not going to do one right now because they're too difficult to draw. I think it might, but things start to get a little bit tricky about how you do the enumeration there. I know it works for ladders, but I'm not sure it works properly for branching. It actually probably does, because the way that that's encoded, you have the different brackets for that. I mean, I think it might work, but I'm not 100% sure.
Okay, thank you.